Highlighting this report period was the launch of the fifth Saturn flight vehicle SA-5. SA-5 was scheduled for launch in December, but was rescheduled for late January due to a problem with cracked sleeves in pneumatic lines of the S-1 stage and instrument unit. Late January 28th, the final countdown began. The only hold was called at T-13 minutes because of RF interference on the C-band radar and command destruct frequencies. The count was picked up 73 minutes later when range safety gave clearance.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
At 11:25 a.m. on January 29th, the vehicle lifted off. SA-5 was the first Saturn I vehicle carrying a live S-4 stage and an active instrument unit. It was the first flight of a Block II booster and the first flight from Launch Complex 37B. The payload was a Jupiter nose cone with 9 1/2 tons of ballast. Throughout the flight, the vehicle performed satisfactorily. Selected critical areas were monitored by onboard cameras. Fuel consumption, which was recorded inside LOX tank number 3, occurred at a normal rate. Chill down of second stage engines prior to stage separation was also recorded. Final booster engine cutoff occurred at 147 seconds of flight, with stage separation 4/10 of a second later. Approximately 2 seconds after separation, S-4 engines ignited and burned for 8 minutes. The payload and the burned-out S-4 stage, weighing almost 19 tons, was the heaviest weight ever orbited. On February 7th, the booster and the instrument unit for the 6th Saturn I flight vehicle, SA-6, were barged from the Marshall Space Flight Center. They arrived at Cape Kennedy on February 18th. S-16 erection on the launch pad began the following day. On February 22nd, S-46 was flown from DAC's Sacto facility to Cape Kennedy. The stage was moved to the hangar where the LH-2 and LOX tanks were entered. Leak tests revealed several faulty welds on the LOX side of the common bulkhead. Following repair, the stage was erected on the booster during early March. On March 11th, the instrument unit was erected. The Apollo boilerplate spacecraft, the first scheduled for flight, will be placed atop the launch vehicle early next quarter. At Marshall, replacement of critical tubing assemblies on the booster for the 7th flight vehicle, SA-7, was completed by February 11th. Post-static checkout, which resumed after tubing replacement, neared completion by the end of the quarter. The stage is scheduled to arrive at Cape Kennedy in early June. Replacement of critical tubing assemblies and pre-static checkout of the booster for the 8th flight vehicle, SA-9, was completed early this quarter. The stage was moved to the static test stand in mid-February and prepared for static testing. On March 13th, the booster was successfully fired for a duration of 35 seconds. Later, on March 24th, a successful long-duration firing of 145 seconds was accomplished. Test data is being evaluated. Post-static checkout of the stage is scheduled to begin in early May. At Marshall's Michoud operations, replacement of critical tubing assemblies and checkout operations for S-18 are complete. At the end of the quarter, the Chrysler-built stage was being prepared for shipment to Marshall for static testing. Chrysler assembly of S-110 continued throughout the quarter at Michoud. Fabrication and installation of critical tubing assemblies was completed during the quarter. Installation of the H-1 inboard and outboard engines was completed in March. Suction lines for the locks and fuel containers were attached to the engines. Also, installation of the inboard suction lines forward of the engine area was accomplished. Checkout is scheduled to start next quarter. The Douglas-built S-47 stage was shipped from Santa Monica to Sacto early in February. The stage was placed in the stand and is being prepared for acceptance testing scheduled for early next quarter. At Santa Monica, DAC completed S-49 assembly in February and stage checkout was underway. Completion of checkout was scheduled for early next quarter. Meanwhile, S-48 assembly was in progress, with installation of the forward and aft telemetry underway. Completion of assembly and initiation of stage checkout are scheduled for April. Also at Santa Monica, the S-410 stage has been installed in the hydrostatic tower for necessary leak checks. Completion of assembly for this stage is scheduled for late this summer. During this quarter, at Douglas's Sacto test facility, attempts were made to static fire the all-systems vehicle for the first time. Minor difficulties caused delay of firing on the first two attempts. On the third attempt, an explosion occurred caused by overpressurizing the LOX tank. The explosion resulted in the complete loss of the vehicle, plus moderate damage to the test facility. NASA and DAC committees are investigating and will prepare a report on the circumstances related to the incident. Meanwhile, Douglas has performed a general cleanup of the area and restored and repainted the stand structure. Further activity on the stand has been discontinued. At Marshall's Manufacturing Engineering Laboratory, assembly of the instrument unit for the 7th Flight Vehicle SA-7 was completed early in February. Checkout began in February and is scheduled to be completed in May. Testing of the SIU-9 vibration test unit began at Wiley Laboratories, Huntsville, Alabama, on January 20th and is on schedule. Assembly of the flight unit, SIU-9, began March 2nd and was proceeding satisfactorily. Completion of unit assembly is scheduled for next quarter. Structural fabrication of the SIU-8 shell was completed at Marshall in February. The unit will be stored until late next quarter, when assembly is expected to begin. At Marshall's P&VE laboratory, separation testing of the boilerplate service module adapter was completed during this report period. The test objectives were to determine if the system provided a reliable and compatible separation and ejection between the adapter module and the Apollo service module. Final analysis of the test program indicated that the present system, using explosive nuts and high-force springs, is highly reliable. Test results also enabled engineers to record the relative velocity during separation of the service module from the adapter module. At Marshall's test laboratory, dynamic testing began in March using the SA-9 configuration upper stage, instrument unit, Apollo boilerplate, and a water-ballasted dummy micrometeoroid capsule. The start of SA-9 dynamic vehicle testing was delayed to complete micrometeoroid service module separation tests. Dynamic testing is scheduled for completion in July. At Marshall's Manufacturing Engineering Laboratory, fabrication is in progress on a Saturn IIB and Saturn IIU structural test unit. Also, fabrication is in progress on a Saturn IB IU vibration test unit. Assembly for both units is scheduled for next quarter. On March 18th at Chrysler Michoud, work was begun on fabrication of the first S1B stage with pre-drilling of the spider beam center hub fittings, and spline plates. Assembly of spider beam parts started within a week, with qualification testing of the beam to be completed early next quarter. On February 24th, Chrysler began outrigger modification of S1 111 and 112 tail sections to the S1B configuration. The 105-inch LOX propellant tank was shipped from Michoud to the subcontractor for modification to S1B configuration. Outriggers and propellant tanks were made available through cancellation of Saturn I production vehicles. At Marshall, installation of insulation of the liquid hydrogen test tank is underway. The tank will be used in Marshall's J2 engine test program. A plastic shroud was placed over the horizontally positioned stage to allow work to continue regardless of the weather. Fabrication continued on the first S4B-1B flight stage at Douglas's Santa Monica facility. The common bulkhead bonding operation was completed. Also, fabrication of the second flight stage began on the 1st of March. At Huntington Beach, S4B structural test stage assembly began in February. The LH2 forward dome mating was delayed due to a faulty weld repair area. The S4B dynamics test stage forward dome was substituted and assembly completed. The stage was moved to tower number 2 for additional aft skirt machining. The original structural test stage dome has been repaired and will be used on the dynamics test stage now in assembly. At Sacto, work continued on the S4B battleship test stage with installation of instrumentation, fill and drain valves, vent assemblies, and other related components. Cold flow testing is scheduled for late next quarter. Also at Sacto, construction is well underway at the Bader Test Complex. Supporting facilities, power supplies, instrumentation tunneling, and evacuation systems are complete. Data reduction support equipment is being installed in the Test Control Center. Components and instrumentation on the Beta 1 stand continued during the quarter, and checkout of the various systems is in progress. Meanwhile, construction of the All Systems Test Stand, Beta 3, continued during this period with installation of structural steel and building of propellant storage tanks. Battleship ground support equipment for the Beta Control Center arrived during the report period and was installed. Completion of GSE installation is scheduled next quarter. This manual GSE will be converted to automatic for acceptance firing of S4B stages early next year. At Canoga Park in Rocketdyne Structural Laboratory, a hydraulic gimbal test fixture has been placed in use to test the J2 engine gimbal bearing assembly in cycling operations. Testing of the J2 thrust chamber assembly determines thrust chamber and component deflection under given load condition. In Rocketdyne's vertical alignment stand, J2 thrust chamber alignment is calibrated through a series of optical and circumferential measuring guides. Also during this quarter at Rocketdyne, ground support equipment personnel proof load tested a prototype J2 vertical installer. The unit will be used to facilitate the installation of the J2 engine into a test facility or vehicle stage. The vertical assembler is controlled by a remote electrical panel and is self-propelled in both the vertical and horizontal position. Static firing tests of the J2 engine were continued by Rocketdyne at its Santa Susana test area during this quarter. Test objectives included evaluation of a new pressure control valve used to close the main LOX valve, heat transfer data, and data on engine performance repeatability. Test results proved satisfactory.